right, good morning. This is Tuesday, January 25th. I know a lot of band kids are probably watching this, so hopefully this will be a great recording. We're starting out with our warm-up, so please pause and we'll complete this and then play the video when you are ready. We are finding the value of n. All right, before we find the value of n, let's just remind ourselves of what n means. What were some things we said n was?
Your rate of change.
It is my rate of change. It is my slope. Bruna?
Multiplier.
It is whatever I'm multiplying by, my multiplier. Okay, I also can find it. There's a couple ways I can calculate my slope. How can I find it?
You can do change in y over change of x.
Very good. Change in y over change in x. Rise over run. Very good. Rise over run. That's probably the one that I use when I look at a graph, and this is more the one I look at in either a graph or a table. I use change in y over change in x more often, but those are all versions of m that we talked about yesterday. So let's go ahead and find it. Okay, so again, I'm going to do it both on the graph and on a table because I find comfort in tables, but I also know that it's sometimes easier on a graph. Okay, my rise, that's talking about my change in y. If I'm looking at these 2 points right here, let's go ahead and get those ordered here. This first one would be 0, 10, and this would be 30, 7. Very good. If I'm looking at that change in y, or my rise, what's going to be different about my rise in this case?
That 30 over 7 is below.
It's below. So that rise, instead of going up, my rise is actually going down in this case. And so that means that my rise is actually going to be what kind of number?
Negative.
A negative number. And that's okay. Okay, so how much is it going down in that case?
3.
It's going down 3, so I'm going to put a negative 3, and then my run is still in a positive direction, which is over 30. It was tricky, yes, 30. Okay, so let's plug that into whatever form I like. My rise again was negative 3 over 30. That can simplify down to negative 1 over 10. What decimal form is that? Negative 0.1. Okay, are we good with that?
Yeah.
Okay, let's do it from a table as well in case that is more of your speed. I'm going to take these coordinates and make a table out of them. I'm going to put x, I'm going to put y. I always like to go in increasing x order, but it really doesn't matter. So I'm going to put 0, 10, and then I'm going to put 30, 7. Let me scroll this down. Okay, again, to calculate, I find the change in y over the change in x. What is my change from 10 to 7? It's subtracting 3. What is my change in y? Plus 30. So if I put that change in y, we said was taking away 3. And then my change in x, we said was plus 30. Again, that would give you that same thing. Are we good with that?
Yeah.
Okay. Either way. So what do we notice is different about this rate of change versus a lot of the ones that we looked at yesterday? There's a couple things.
That instead of going up for the rise, you're going down.
Okay, I had my slope is like going down. It looks like I'm going down a ski slope. And so how is that reflected in the number that is my rate of change?
It's being
It's a negative. If I have a negative slope, that means my line is going to go down. Like negative. It's a negative slope. Y'all good with that?
Yeah.
Okay, just some observations to make. All right, we're going to go over homework real quick. If you have that and you're at home, I would check to see on Canvas. A couple things to note. First one, number 4, it was not linear, so it did not have a constant rate of change if you actually solve for it. Some other things, I know the equations over here gave some people some trouble because you were like, wait, what? But if you remember on that first formula slide, we said that my slope is the same thing as my multiplier. So we just needed to look at my multiplier in each case. That is my slope. That is my rate. Any other ones I can go over? Yes. Number 7. Okay, finding the change in y. I wrote that it was plus 4. Do you agree with that? And then my plus 2 in my x. Change in y over change in x. 4 over 2 simplifies down to 2. Is that the one you wanted?
Yeah.
Do you see that?
Yeah.
Good. What else? Number two. Number two, I think people put 4 instead of 1/4, so let's look at why. So they did like this point and then this point right here because it's got a nice cross section. If you did rise over run, it went up 1 and it went over 4. Okay, so that would be the same thing as 1/4, 4.25. A lot of people did run over rise on accident, but you have to be careful because the number of quarters matters. Okay, any other questions? All right, let's put that away and let's get our notes out. Hopefully, if you're on a Basecamp, if you stop by and jot your notes so you have a little copy of yourself. So I mentioned yesterday, last week we spent a lot of time talking about additive versus multiplicative. Today we are combining the two. These two-step equations, okay, we might have a multiplier and something that you subtract or divide and add, whatever. Okay, we have this equation to help us as our template for these two-step equations. Now let's go through and break down each letter, just reviewing what they are talking about. We said that my y is my dependent or my output, right? I think that's easier to think of as my output, but you can put dependent on there as well. I love that you're thinking of that. Okay, therefore my x is my, no, it's my, x is my input, or my independent. Okay, that has not changed. Okay. Then we said m is our multiplier, but the fancier, nicer word is rate of change or slope. I'm going to put those. I'm going to say rate of change, or I'm going to put my slope. Those are the fancier words that I like. Those are more mathematical, even though multiplier isn't. Okay. And then B is whatever I'm adding or subtracting, but I gave a math term like yesterday. Y'all remember? Y-intercept. Y-intercept. That's going to really come into play today. You're going to see it a lot more. But again, you can think of what I add or subtract in the equation. Okay? Again, that y-intercept is really going to come into play today. Okay? Let this be a come back to like a home space where you come back to when you're like, wait, what does each letter mean? Because it does get confusing and it takes time to practice to get there. Okay, so just like always, in order to find my equation, I'm always going to find my rate of change first. Okay, that's just an easiest way to figure out if I need to multiply or not. When I find that rate of change, what I need to do is I first need to pick 2 points. Pick 2 points. Okay, so I'm going to do on this first one, I'll do this one, and I'll do this one right here. What do we already know about this graph? It's probably multiplicative because through the origin. Okay, so let's just check and be sure. Okay, so I'm going to do the rate of change both ways on a graph and on a table. So we can do rise over run. How much did we rise?
2.
And how much did we run?
4.
4. Very good. Okay, so if I did rise over run, that'd be 2 over 4, which simplifies to
1/2.
1/2. Do we agree? Okay. I'm going to, of course, check it with the table in case you like tables more. So I'm going to get those ordered pairs. We know that this goes through the origin, so that's 0, 0. This one over here is going to be 4 over comma 2. Okay. If I wanted to make my table, x, y, 0, 0, and then 4, comma 2. To find that change in y, what's changing in my y?
+2.
Plus 2. What's changing in my x?
+4.
Plus 4. Again, to find the rate of change, change in y over my change in x. We said it was a change of 2 over a change of 4, which is the same thing as 1/2. Do those both agree with each other?
Yeah.
Yes. Do you have to do both ways? No. It's whatever you like better. Okay? So this is my rate of change. So this is going to go into my template equation as my m value. Okay? I'm just going to start with y equals 1/2 x. Y equals 1/2 x. It's always a good idea, it says right here, does the equation work as is, or do I need to add or subtract anything? Okay? Last week we just did 1 step, but now we're going to start doing 2 steps where we might have to do 2 things. So let's just check. Pick either of the points that we've used, and let's check and see if it works. It's never really a good idea to use 0, 0 because it's 0, 0. So let's go with 4, 2. If I put in 4 as my x, will I get 2 out? If I do 1/2 of 4, does that equal 2? Yes. So did I need to add or subtract anything? No. Okay, it's just a plain old multiplicative. And we said that already because it goes to the okay? Plain old multiplicative. All right, this second graph, what did we notice already? Is it multiplicative? It could be additive, okay? But it's not going through the origin, so I know I'm going to need to add or subtract something. Okay? So let's take a look. Again, we're going to find our rate of change first. You can either do rise over run or change in y over change in x. I'm going to go ahead and pause and let you figure it out. All right. All my class is working. I'm going to go ahead and give myself some points. I like this one is 0, -2. And this one is 2, 0. I'll do both ways, but again, you only need to do one. If I did rise over run, that's +2. My run is +2. So if I put 2 over 2, that would simplify to 1. If I did my table, x and y, 0, -2, and 2, 0, again, that's +2, that's +2. Change in y, we said was 2 over my change in x was 2. Again, simplifies to that same thing. So that, again, 1 is my multiplier. But when I multiply by 1, does it change anything?
No.
And if I multiply any number times 1, does it change anything? No. Okay? So putting that 1 in my equation really doesn't do anything. I could write y equals 1x, but again, that 1 doesn't do anything, so I'm honestly not even going to put it there because it's useless. Okay? I'm just going to put y equals x. Now, you have to ask yourself, do I have to add or subtract anything? Does the equation work as is? If I plug in one of these points, if I plug in 2, does that equal 0? No. Okay. So do I need to add or subtract something? Yes, I do. What do I need to add or subtract? Do I need to add or do I need to subtract? To go from 2 to 0. I need to subtract how much? -2. So in my equation, it's going to be x minus 2. Okay? If you're ever unsure that your equation works, you should always check. Even if you're sure that it's right, you should still check. I'm just going to pull another random point. I'm going to pull this guy up here. The ordered pair for that is 4, 2. I'm going to check it with this new equation that I've just written. If I put in 4 minus 2, do I get 2 out? Yes, my equation works. Okay? So was this additive or multiplicative? It was additive. Okay, let's also take notice. We said that this value that I add or subtract, we said that's called my y-intercept. And that's because if I look at my graph, where is it hitting the y-axis? It's hitting right here. And what's that number that's with it? 0. No, there's 0, but it also -2. That y-intercept where it hits the axis will always come into play in your equation. That -2 there, where it's hitting that y-axis, that's why it's called the y-intercept, will come into play into your equation. And again, we're going to start seeing that a lot more today. We'll be like, okay? Huh? Okay, let's do one more and you'll see it. It takes a little bit of time. Okay? So we're going to do it some more. I'll do one more with you and then I'll let you try and find it out. Okay? I'm already noticing on this graph, is it going through the origin or not? No. Where is it hitting the y-axis? What number is that? 0, 3. So that y-intercept, I already see that's hitting at 3, +3, right? Mm-hmm. Okay. Let's figure out that rate of change though. Okay. I'll go ahead and use that point right there. It's 0, 3. What's this point right here where it hits? That's at 1,5.
Oh, wait, isn't it?
Again, it's not -5 because it's going up. That's just the grid line. We talked about that. Let's find that rate of change. So either way you like to do it, it went up 2 and it went over 1. Okay, so that rise over run was 2 over 1, which simplifies to 2. My rate of change is 2. So let's plug both of those values into that y equals mx plus b. Okay? My rate of change is the same thing as my m. My y-intercept is the same thing as my b. So I'm just going to see if it works out. If I put y equals m is 2, x plus 3. You'll see how I wrote that equation, where I got those numbers. Okay, let's see if it works, because I'm just blind going in like, I don't know if it works. Okay, the way you check, we'll pick a point. I'm going to put in 1, 5. If I put in 1 for x, do I get 5 out? 2 times 1 plus 3. Does that give me 5?
No.
Check it again if you want to. If I put in 0 plus 3, does that give me 3? 0. Y'all see how I'm doing that? Sort of, kind of. If you're not sure, you're like, let's break it down. Okay? Let's break it down. Okay, on that next problem. Go ahead, find the rate of change. Find the y-intercept. See if you can put it together. Pause and play when you think you've got a guess at it. All right, let's find that rate of change. Okay? I'm going to pick, again, I could pick different ones than you, but I'm going to pick these 2 points right here. I see that it went up 1 and over 4. So my rate of change would be
1 over 4.
1 over 4. Did y'all get that?
Yes.
Is 0.25 the same thing? Yeah. Absolutely. I would accept it just as equally. Decimals and fractions. All right. So if that y-intercept is confusing you, let's just start with that. Let's do y equals 1/4 x. And let's see if that equation works. Again, the way to check to see if the equation works is pick one of the points. I'm going to go for that one. The ordered pair for that point would be 4, 0. If I did 1/4 times 4, hold up, what's happening? Oh yeah, would that give me 0, class? No. 1/4 of 4 is 1. What do I still need to do to 1 to get to 0? -1. And again, where do we see that -1 on our graph? It is my y-intercept. It's at -1. Okay? It's the same thing. Okay? I heard some, if it's still digesting, that's fine. Okay? This is one of those, and for people at home as well, this is one of those lessons where we really want you to maybe go to a different tutorial. Okay? Miss Idle might explain it one way, Miss Balance might do it another way, Miss Spark might do it another way, and then Miss Front might do it a completely different way. All of them are linked. Okay? It's just whatever we're sort of comfortable with is usually what we teach y'all. Okay? No, right, all right, so that's a graph. Let's do it from a table. Next page. Oh. Next page. It's going to be the same exact steps. We're going to find the rate of change. We're going to find the y-intercept / what we need to add or subtract and check that equation. Okay, let's start with that rate of change. What's changing here? What's changing in my y? Oh, wait, which one's my y? Okay. Is it okay to put a label next to it? All of them. Okay. What's the change in my y? That's plus 12, right?
Oh, yeah.
Oh. But then this one's plus 8. Is it constant? I don't know. Let's check. I don't know. Yes or no. Okay. This one's plus 6. This one's plus 6. Okay. So let's check the top. What's changing in my x on the first one is plus. The next one is
plus 1.
Oh, so that one's okay. So they're different. Let's just double check. Plus 1, plus 1. If I do that change in y over change in x for the first set, for that 12 and 2, change. What does 12 over 2 simplify down to? 6. If I did the next one, 6 over 1, what does that simplify down to? 6. So is it still a constant rate of change? Yes. Miss I was trying to trick you and make you doubt yourself, and here we are. Okay? But it simplifies to the same thing. My rate of change is 6. Okay? Again, that's my multiplier, so I'm going to go ahead and put that in my y equals 6x, and I'm going to check with a point. I'm going to see if I still need to add or subtract something. Okay? Gabby, which point do you want to use? Which x value do you want to use? 318, okay? So we're going to plug in 3, see if we get 18 out. 6 times 3, class, does that give me 18? Yes, it does. Okay, so do I need to add or subtract anything? No. What about my table tells me also that I don't need to add or subtract anything? There's something in my table that says I also don't need to add or subtract. Y'all see it?
0,
0, 0. Very good. So the answer was no, and the reason is because it goes through the origin, so I don't need to add or subtract anything. It all sort of ties together. Very good. Yay! Or hey, not. All right. Do y'all want to try one on your own?
Yes.
Okay, so. All right, let's find that rate of change. What did y'all see in the change in y? Plus 9. Okay, what happened in the x? Plus 3 every single time. When I put the change in y over the change in x, I put 9 over 3. Simplify it down to 3. My rate of change is 3. Again, you can go ahead and plug that into your equation, the y equals 3x, and you can see what you need to add or subtract. Micah, what point would you like to use? What point do you want to use to check? On this one. Which x value do you want to use? Doesn't matter which one, just pick one. 6, okay? We're going to plug in 6 and see if we get out 14. If I plug in 6, 3 times 6 is 18. It tells me I need 14. What do I still need to add or subtract to get there? Bruna? Minus 4. So let's check that. I'm going to add that into my equation, and I'm going to just check it with a different one. Okay, I'm going to use 9 and 23. If I do 3 times 9 minus 4, does that give me 23? 3 times 9 is? 27. Minus 4 is? 23. So my equation is that both 3x minus 4. Where else could I see that minus 4 coming into play? Bruna?
It's the Y-intercept.
It is the Y-intercept. Again, when x is 0, it says my y is -4. So that -4 is my Y-intercept, and that's why I got plugged into my equation. Okay? The Y-intercept, it's sort of up to you how you approach it. Some people like doing it at the end. Some people like looking at it from the table. Okay? So let's just do one more together, and then honestly, you'll be all good to go. Finding that rate of change, what do we see?
Plus 1.
Besides just the what do we see?
Plus 1.
Great. Okay, over here, what do we see?
Plus 1.
Plus 1. Uh-oh, what's my rate of change going to be?
1.
1 over 1, which is what? 1. Does that do anything? No. Okay, so in my mind, I'm already like, I'm going to need to add or subtract. Okay, let's see what we need to add or subtract. Because right now, again, it's the same thing as saying 1x, which isn't anything. Okay, that doesn't really change anything. So I like to plug in, okay, if I have a 6 going in, how do I get a 10 to come out? I need to add 4. So let's check that with my equation. Okay, let's pick another point. If I put in 3, 3 plus 4 is 7. 4 plus 4 is 8. Okay, on this table, do I have my y-intercept?
No.
No. Okay, again, my y-intercept is whenever I have x to be 0. Okay, I can show you how to find that if it's not there. Okay, you just notice, okay, every single time it's going up by 1 on the x, it's also going up by 1 on the y. Do y'all see that? Okay, but if I go from 3 to 0, I need to do 3, that's 3 down, so I need to do 3 times as much on the x as well. So if I go down 3, down 3, I would also need to go down 3 here. And so if I go 7 down 3, that would give me 4. Okay, so that 4 is my y-intercept. That's where it comes in. That's a way to do it. If what I just did not make sense, go talk to Ms. Bella. She's beautiful at explaining it. That is her jam.com.org.gov. Okay, that's her. She loves explaining it that way, and I love that. Okay. All right, so just to summarize everything we talked about, every single time, whether it's from a table, whether it's from a graph, you first identify what was the first thing you found? My rate of change. My rate of change or my slope. Okay, the way to find our rate of change or slope is to find rise over run, or the change in y over the change in x. Again, this is my multiplier. That's your m in the mx plus b. After you get your rate of change and multiply it by x, if you do not get your y values, you figure out what you need to add or subtract. Very good. To get there. This value is called the Y-intercept. Very good. We're like 30 seconds in. I thought of something. Well, I was just recording here's the value. All right. Yeah, that's it. Sorry. The value is called Y-intercept because it's where it crosses the y-axis. Are we good with that?
Yeah.
Okay. So what I want you to do, again, I want you to settle this into your own brain without Miss Lytle doing it. So go ahead and do this page on your own. In a few minutes, we'll check it. If you finish that, go over your homework. But if you're on the video, just pause and play when you're ready with that page. Alrighty. So, oh, sorry, putting up the key for that page. First, you were pretty good. 9x. I saw a lot of y'all have 9x. On this second one, it pulled a fast one on you. The change in y was +3, and when it went over, it only went one square, but each square is worth 3, so that's also +3. So 3 over 3, that rate of change equals 1. We pulled a fast one on you. Then when you figure out what you need to add or subtract, it is -2. -2 is also your y-intercept. Okay, next one, 1/2 x plus 2, and then 3x plus 2. Again, I'll do this with a blank one real quick. I'll show you how to find that y-intercept. I found that the rate of change +1 + 1 + 1 + 2 + 2 + 2. My rate of change is changing y over my change in x, which is 1 over 2. Y equals 1/2 x. If I plug in any random point, so let's say 8 and 6, if I do 1/2 of 8, does that give me 6? The answer is no. What I still need to add or subtract is, if I do 1/2 of 8, that's 4. I still need to add 2 to get there. Okay? If you're looking for the y-intercept on this table, okay, again, the way that Miss Ballish does this, okay, she sees that, okay, this is going by 2, by 2, by 2, by 2. If I were to work back to my 0, that'd be that same jump. So jumping the same -2 here, I was adding 1 each time, so I need to go backwards the same amount, -1, so that'd be 2. Let me try that one more time. Okay, each time you were increasing by 2 and increasing by 1. To work back to 0, I'm going by that same interval, it's still by 2, so I still need to go by 1 on the y. And so I'm going down since I go backwards, so that would give me 2, which is that y-intercept. Okay? Again, she's a lot better at explaining that. I'm not even going to say a little bit better, she's a lot better at explaining that. I just like to think of y-intercept. Okay? So that is that. The back page is your homework. Please go to tutorials. Please go to a different teacher. Be awesome. Good night.